Okay, in this video, I want to talk about the synthesis of carboxylic acid derivatives. And you have two, major categories of things. You want to think about, is there a change in the carbon count? Okay. If there are, you want to think about how you would introduce additional carbon-carbon bonds. Carbon-carbon bonds can be made from Grignards or cuprates. Now, the other thing you want to think about are there additional carbons, okay? Carbon oxygen or carbon nitrogen. I call these additional. Material, and these can come from alcohols and amines, okay? Primary, secondary amines or alcohols. And you can also have basic functional group transformations. Okay, and look at all the ones we've looked at. We've looked at carboxylic acids, acid chlorides, acid anhydrides, nitriles, amides, okay, and esters. So think about how the functional group is changing and what you might have to do to accomplish that, looking at the functional group chart on the other page. Okay. Now there's a lot of different synthetic reactions where you might have to do a couple of different reactions. So for example, your book talks about going from something like this to something like this. Okay. Now you got two carbons there, and you've got two carbons there. So this is an example of a functional group change. Okay. Now, if you're going from something like this is an example of a carbon change. You have the same functional group. You have one carbon here, and you have two here. So you're going to have to introduce an additional carbon-carbon bond in some way. Okay. So that's the first step of the analysis, trying to figure out, well, how many carbons are there? Is there a functional group change, and so on and so forth. Okay. And so let's do problem 2135 together from the Klein textbook on page 1032. And so we have part A. We have benzoic acid. And we want to make this molecule here that has, it's an alcohol. It's still aromatic. And it's got two additional carbons. So the functional group's changing. And we have an ethyl group. Okay. Now, looking at the target molecule, I would think backwards, and I would review maybe aldehydes or ketones or something like that. And I would think, well, this could come from an aldehyde and a Grignard. Okay. So that's chapter 20. This chapter, we could think, well, that could come from possibly this guy, which could come from an acid chloride and a cuprate. Okay. So I'm going to use the newer technology to do that instead of just using old stuff from chapter 20. So what I would do is take my carboxylic acid, I would treat this with thionyl chloride to give me an acid chloride. Then I would treat this with my cuprate to give me the phenylethyl ketone, and then I would treat this with sodium borohydride to give me my target molecule. Okay, so that's 3 relatively simple steps. Okay, many of these synthesis problems are 3-4 steps, something like that. Okay, let's look at problem B. I'll switch colors here so you can recognize I'm working on a different color, different problem, I mean. So we've got bromobenzene, and I want to convert this to this ester. Okay, so let me just verbally express, out loud what I'm thinking. I'm thinking that this molecule right here can come from an alcohol and, some acylating reagent like acetic anhydride to stick that acetyl group on there. I'm missing a carbon here. I want to watch out and make sure we don't do that. So there's my carbon. Okay. Now I need to figure out how I can take bromobenzene and make it have 1 additional carbon. And here's where you want to think backwards through the process, and this can come from formaldehyde, right, which can react with a Grignard, for example, a phenyl to give you something like this, right? And then that protonates to give you the benzyl alcohol. So I'm going to use formaldehyde and a Grignard and acetic anhydride as my starting materials. And of course, the bromobenzene given to me. So in the forwards direction, I would take my bromobenzene. I would treat this with magnesium in diethyl ether to give me phenyl magnesium bromide. Then I would treat this with formaldehyde, do a water workup, and that would give me benzyl alcohol. And then I would treat that with acetic anhydride, and that would give me the benzyl acetate there. So that's 1, 2, 3 steps. Okay? Many of these synthetic reactions are maybe 3 steps, 3-4 steps. Okay? All right, let me work on problem C with you here together. We've got cyanobenzene, or benzonitrile, and we want to convert this to this guy here. So this carbon is presumably that carbon. And so we're adding two new things to this. Okay. And we need to acylate or get this ester on there. Okay. So what you can do here is how are we going to get two R groups? Two R groups. There's a couple of different things we could think about. One is to just treat this guy here, this nitrile, with a Grignard reagent. And we do water workup, remember? Okay, and that's a ketone, all right? And if we do that again, we can get to an alcohol. I'll draw it in the same orientation as the target molecule. And then we can treat that with acetic anhydride to get to the, reaction products. Now, another way we could do this is it's more lengthy, but we could add water, acid, and heat to make this the carboxylic acid. We could convert this to methanol, convert this to the methyl ester using methanol and acid. And then in one step, we could add 2 equivalents of our methyl magnesium bromide. And then step 2, do the water workup, and then do that. So that would be 1, 2, 3, 4 steps. Or in green, that would be 1, 2, 3 steps. Okay, so 3 or 4 steps. There's always going to be 2 or 3 or 4 or 5 different ways you can synthesize these different products that you're trying to make, especially in this chapter, because there's so many different derivatives and different methods and ways that you can do things. The review of reactions at the end of Klein is very useful. It goes through many of these different things, and I'll post some homework that's very comprehensive and a big review sheet for you to look at. So thanks for watching.